So in this exercise, we're going to look at two pieces of code and we're going to decide which one is the best one for this situation. There are two pieces of code. You are going to have to be able to figure out which kind of code will give you the fastest route to the delivery point. And remember, you must deliver the package in one piece and in 1 hour. So, let's see what we're going to do. So, let's check it out, shall we? The first thing we should do is change the view of this. It's much easier to see from above. Like so. And now we can count all the blocks. Let's reopen our code layer and check out the first one here, called print A. So if we look at the drone, it's facing the opposite direction from the target. And so we've got the drone turning right, and then going forward 5 steps, and then going left, and then eventually going forward. So is that the fastest way? Remember, we only have 1 hour to do it. Let's have a look at print B. Now, it just wants to go backwards, so that's already quicker. It's going to go backwards 6, and then go right, as we can see. Oh, traffic. Oh, I think we're in the middle of traffic. And then we're going to just quickly go to the target. We're going to land, and then we're going to release the package. So this really is the fastest one. So what we're going to do is delete the one that we don't want. We're going to click on the one that we want, and then we're going to go to the play button. Let's see what happens. And it's looking good, and we are there. We did it. Excellent. So now it's your turn. Now that we have the basics mastered, let's take this to the next level, shall we? So we can use a single block for every single movement here. So we can do that here. That would be, what, 12 blocks in total. So we can throw out a few blocks here. 1, 2, a couple more, 1 more, and a turn. And we can do that many times. So let's show you a different way to do it. I'm going to throw this all away, and we're going to introduce you to loops. So we're going to drag a loop. This is a green loop square. And we're going to drag in just enough to do one side, just one side. So we're going to throw in 4 move blocks. 2. Got 1 more coming in. And we're going to put in 1 turn. Now, this doesn't work for every situation, but because this is a square, this is ideal. So rather than doing one for all of them, what we're going to do is count in how many times we need to repeat it, and in this part we're going to do it 3 times. And when we press play, it's going to go through that nested loop section 3 times. Now watch the robot. 2, and it follows all the way down, and 3. Well done. We've just mastered loops. This is very efficient and very important if you're going to be coding. And so now it's your turn. This is how real robots work. So our task is to find all the trash in the sea and use a sonar pinger to tag that piece of trash so we can find it later and collect it. A pinger is a small device that makes a sound. It makes a pinging sound. And that sound can be detected from a special sensor that's on the submarine that will be used to collect that trash later on. This green arrow shows you which block you need to look for. First, we're going to find the loop block, which is found in the green loop tray. And then we're going to place it underneath the red dropper ping. Then after that, we will put a print block inside the loop. You'll find the print block inside the text folder. I'm going to open it up here, find it at the bottom there, and drag it inside that green loop. We will need to know how far we are away from that pinger. So we're going to get the get distance to pinger block, and we're going to put that inside or alongside the print block. We're going to talk more later on about what the KHZ actually means. This is very important. And so we want to keep things calm and chill, so we're going to stick a 1 second delay block underneath that print block. Like so. And last up, let's get some math going and add a number to the top red block and to the get distance block inside the loop. This number will be the frequency, which is measured in kilohertz, the pinger will actually be. By giving each pinger its own unique identification number, the submarine will not go to the wrong pinger later on. Now we need to make these numbers both the same, so let's stick them both at 30 kilohertz. And so now the code is complete. Let's put this in the corner there now and press play, and let's see what happens. Down goes the pinger and up comes a terminal window, and the terminal window now shows all the data which is coming from that pinger. I think we can declare this a success, and now it's your turn